Hello viewers, welcome to my channel Online Biology Tutorials. In this live of today, we will be reading Chapter 2, Acids, Bases and Salts. This is Class 10 Science chapter taken from NCERT, followed in CBSE board. However, I already had one of the video series on the audiobook of Science Class 10, but that was with the background music. So due to continuous request, I am recording without background music because once you are concentrated, you just want to focus upon the words only. So requesting everybody, whenever you will be hearing the audio, please do share it with your friends as well. I hope the screen is clear to everybody. The text is clear. Let's begin with the reading of Chapter 2, Acids, Bases and Salts, Class 10. Science NCERT followed in CBSE board. You have learnt in your previous classes that the sour and the bitter taste of food are due to acids and bases respectively present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, or baking soda solution? Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and the bitter substances without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. Have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. In this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day to day life. Now, this small block of do you know? Litmus solution is a purple dye which is extracted from lichen, a plant belonging to the division Thellophyta, and is commonly used as an indicator. When the litmus solution is neither acidic nor basic, its color is purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, and geranium, which indicate the presence of acid or base in a solution. These are called acid base indicators or sometimes simply indicators. Next page. First, we'll be reading out the in-text questions. I hope the screen is visible. First in-text question, you have been provided with three test tubes. One of them contains distilled water and the other two contain an acidic solution and a basic solution respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? 2.1 Understanding the chemical properties of acids and bases. 2.1.1 Acids and bases in the laboratory. Activity 2.1 Collect the following substances from the science laboratory: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, acetic acid CH3COOH, sodium hydroxide NaOH, calcium hydroxide CaOH2, potassium hydroxide KOH, magnesium hydroxide MgOH2, and ammonium hydroxide NH4OH. Put a drop of each of the above solutions on a watch glass one by one and test with a drop of indicators as shown in table 2.1. What change in color did you observe with red litmus, blue litmus, phenolphthalein, and methyl orange solutions for each of the solutions taken? Tabulate your observations in table 2.1. So for all these, you need to write the name here in the sample solution. Then you need to write who is turning red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. Now this page beneath the table on the same page itself, these indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose odor changes in acidic or basic media. They are called olfactory indicators. Let us try out some of these indicators. Activity 2.2. Take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their odor. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and a few drops of dilute NaOH solution on the other. Next page. Rinse both cloth strips with water and again check their odor. Note your observations. Now take some dilute vanilla essence and clove oil and check their odor. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. Add a few drops of dilute vanilla essence to both test tubes and shake well. Check the odor once again and record changes in odor if any. Similarly, test the change in the odor of clove oil with dilute HCl and dilute NaOH solutions and record your observations. Which of these, vanilla, onion, and clove, can be used as olfactory indicators on the basis of your observations? Let us do some more activities to understand the chemical properties of acids and bases. So we are on this topic now. 2.1.2. How do acids and bases react with metals? Activity 2.3. Caution, this activity needs the teacher's assistance. Set the apparatus as shown in figure 2.1. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Past the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas filled bubble. What do you observe? Repeat this activity with some more acids like hydrochloric acid, HCl, HNO3, nitric acid, CH3, COOH, acetic acid. Are the observations in all the cases the same or different? So in figure 2.1, they have shown you reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas by burning. Next page. Now, note that the metal in the above reactions displaces hydrogen atoms from the acids as hydrogen gas and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal will give you salt plus hydrogen gas. Can you now write the equations for the reactions you have observed? Activity 2.4. Place a few pieces of granulated zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the contents of the test tube. Repeat the rest of the steps as in activity 2.3 and record your observations. The reaction that takes place can be written as follows: 2NaOH aqueous plus zinc in solid form Zn will give you sodium zincate. The chemical formula is Na2ZnO2 in the solid form plus hydrogen gas. You will find again that hydrogen is formed in the reaction. However, such reactions are not possible with all the metals. 2.1.3. How do metal carbonates and metal hydrogen carbonates react with acids? Activity 2.5. Take two test tubes, label them as A and B. Take about 0.5 gram sodium carbonate Na2CO3 in test tube A and about zero point 0.5 gram sodium hydrogen carbonate NaHCO3 in test tube B. Add about 2 ml of dilute HCl to both the test tubes. What do you observe? Pass the gas produced in each case through the lime water, which is calcium hydroxide solution as shown in figure 2.2 and record your observations. The reactions occurring in the above activity are written as in test tube A, Na2CO3 solid form plus 2HCl aqueous form will give you 2NaCl aqueous form plus H2O liquid plus CO2 gaseous form. In test tube B, NaHCO3 solid plus HCl aqueous will give you NaCl aqueous plus H2O liquid plus CO2 gas. On passing, the carbon dioxide gas evolved through lime water. CaOH2 aqueous, that is lime water, plus CO2 gas will give you white precipitate, which is calcium carbonate, CaCO3 solid, plus H2O in the liquid form. Next page. On passing excess carbon dioxide, the following reaction takes place. CaCO3 solid plus H2O liquid plus CO2 gas will give you calcium hydrogen carbonate or calcium bicarbonate written as CaHCO3 whole twice in the aqueous form soluble in water. Limestone, chalk, marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids and give a corresponding salt, carbon dioxide, and water. Thus, the reaction can be summarized as metal carbonate or metal hydrogen carbonate plus acid will give you salt, carbon dioxide, and water. 2.1.4. How do acids and bases react with each other? Activity 2.6. Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of phenolphthalein change after the addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think this has happened? In the above activity, we have observed that the effect of a base is nullified by an acid and vice versa. The reaction taking place is written as NaOH aqueous plus HCl aqueous will give you NaCl aqueous plus H2O liquid. The reaction between, so this is the reaction, talking about this reaction. The reaction between an acid and a base to give salt and water is known as neutralization reaction. And in general, a neutralization reaction can be written as base plus acid will give you salt and water. Next, 2.1.5 Reaction of metallic oxides with acids. Activity 2.7. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper to chloride in the reaction. The general reaction between a metal oxide and an acid can be written as metal oxide plus acid will give you salt and water. Next page. I hope the page is visible. Now write and balance equation for the above reaction. Since metallic oxides react with acids to give salts and water, similar to the reaction of the base with an acid, metallic oxides are said to be basic oxides. 2.1.6 Reaction of a non-metallic oxide with base. You saw the reaction between carbon dioxide and carbon hydroxide, which is lime water, in activity 2.5. Calcium hydroxide, which is a base, react with carbon dioxide to produce salt and water. Since this is similar to the reaction between base and an acid, we conclude that non-metallic oxides are acidic in nature. In text questions, there are three. We'll be reading one by one. Question number one, why should curd and sour substances not be kept in brass and copper vessels? Two, which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of this gas? 3. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas involved distinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. 2.2, what do all acids and all bases have in common? In section 2.1, we have seen that all the acids have similar chemical properties. What leads to this similarity in properties? We saw in activity 2.3 that all the acids generate hydrogen gas on reacting with metals. So, hydrogen seems to be common to all the acids. Let us perform an activity to investigate whether all compounds contain hydrogen are acidic. Activity 2.8. Take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix two nails of a cork and place the cork in a 100 ml beaker. Connect the nails of the two terminals of a 6-volt battery through a bulb and a switch as shown in figure 2.3. Now pour some dilute HCl in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? Does the bulb glow in all the cases? Next page, this one. I hope it is clear. The bulb will start glowing in the cases of acids as shown in figure 2.3, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. Acids contain H ion as a cation and an ion as Cl minus. In HCl, NO3 minus, in HNO3, SO4, 2 minus, in H2SO4, CH3, COO minus, in CH3, COOH. Since the cation present in acids is H plus, this suggests that acid produce hydrogen ions, H plus aqueous in solution, which are responsible for their acidic properties. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc. What can you conclude from the results of this activity? 2.2.1, what happens to an acid or base in a water solution? Do acids produce ions only in aqueous solution? Let us test this. Welcome viewers to my channel. We are doing audio of chapter 2 class 10 science. 2.2.1, what happens to an acid or a base in a water solution? Do acids produce ions only in aqueous solution? Let us test this. Activity 2.9, take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown in figure 2.4. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test of the test of gas involves successively will dry with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of dry HCl gas, HCl solution? Note to teachers, if the climate is very humid, you will have to pass the gas produced through the guard tube, or that is a drying tube containing calcium chloride to dry the gas. So this is dehydrating agent. The experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H ion from HCl molecules cannot occur in the absence of water. So HCl plus H2O means water will give you hydronium ion, that is H3O plus chloride and Cl minus. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus or AQ, or hydronium ions are shown as H3O plus. H plus H2O will make H3O plus. We have seen that acids giving H3O plus or H plus aqueous in water. Let us see what happens when a base is dissolved in water. So NaOH, a solid form, when water is added, it will be breaking down into Na plus, that is aqueous, and OH minus aqueous. Next page. KOH solid in the presence of water will form K plus aqueous plus OH minus aqueous. MgOH2 solid in the presence of water or H2O will give Mg2 plus aqueous plus 2OH aqueous minus. Bases generate hydroxide, OH minus ions in water. Bases which are soluble in water are called alkalis. Do you know all bases do not dissolve in water? An alkali is a base that dissolves in water. They are soapy to touch, bitter, and corrosive. Never taste or touch them as they may cause harm. Which of the bases in the table 2.1 are alkalis? Now, if we have identified that all the acids generate A plus aqueous and all bases generate O minus aqueous, we can view the neutralization reaction as follows. So we know acid plus base will give salt plus water. So here, suppose the acid is HX and base is MOH, then X and M will be uniting, forming MX, plus a molecule of water will be produced. So H plus in aqueous form, OH minus in aqueous form is going to give you H2O in the liquid form. Let us try what is involved when water is mixed with an acid or a base. Activity 2.10. Take 10 ml water in a beaker, add a few drops of concentrated H2SO4 to it, and swirl the beaker slowly. Touch the base of the beaker. Is there a change in the temperature? Is there an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations. The process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid and sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to the concentrated acid, the heat generated may cause the mixture to splash out and may cause burns. The glass container may also break due to excessive local heating. Look out for the warning sign shown in figure 2.5 on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or a base with water results in the decrease in the concentration of ions H3O plus OH minus per unit volume. Such a process is called dilution, and the acids and bases are said to be diluted. Next page, please. And we are on in-text questions now. Why do HCl, HNO3, etc. show acidic characters in aqueous solutions, while solutions of compounds like alcohol and glucose do not show acidic character? 2. Why does an aqueous solution of an acid conduct electricity? 3. Why does dry HCl gas not change the color of a dry litmus paper? Fourth, while diluting an acid, why it is recommended that an acid should be added to water and not water to an acid? How is the concentration of hydronium ions H3O plus affected when a solution of an acid is diluted? Question number 6. How is the concentration of hydroxide ions OH minus affected when excess base is dissolved in a solution of sodium hydroxide? 2.3. How strong are acid or base solutions? We know how acid base indicators can be used to distinguish between an acid and a base. We have also learned in the previous section about dilution and decrease in the concentration of H plus and OH ions in solution. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or a base is? We can do this by making use of a universal indicator, which is a mixture of several indicators. The universal indicators show different colors at different concentrations of hydrogen ions in a solution. A scale for measuring hydrogen concentration in a solution called pH scale has been developed. The P in pH means potens in German, meaning power, and pH and on the pH scale, we can measure pH generally from 0 very acidic to 14 very alkaline. pH should be thought of simply as a number which indicates the acidic and the basic nature of a solution. Higher the hydrogen ion concentration, lower is the pH value. The pH of a neutral solution is 7. Value less than 7 on the pH scale represent an acidic solution. As the pH value increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution. That is, increase in the strength of alkali. Generally, paper impregnated with a universal indicator is used for measuring the pH. So in figure 2.6, variation of pH with the change in concentration of H plus and OH minus ions are shown. So before, prior to 7, we have acidic. Beyond 7, we have basic situation. So you can go ahead with your diagram, and this is an important one to remember. Next page. Activity 2.1, test the pH values of solutions given in table 2.2. Record your observations. What is the nature of each substance on the basis of your observations? So in this table, you are being given 10 solutions. You need to test them: color of the pH paper, approximate pH value, and nature of substance. So the substances that are given to you are saliva before meal, saliva after meal, lemon juice, colorless aerated drink, carrot juice, coffee, tomato juice, tap water, 1 molar NaOH, 1 molar HCl. In figure 2.7, pH of some common substances shown on a pH paper like colors are only a rough guide. So moving from 0, this is the color, and see how the color has been showing variations. So this is Vibgyor from higher pH to lower: violet, indigo, blue, green, yellow, orange, red. So this is the color scheme. The strength of acids and bases depends on the number of H plus ions and OH negative ions produced, respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Acids that give rise to more H plus ions are said to be strong acids, and acids give less H plus ions are said to be weak acids. Can you now say that what weak and strong bases are? 2.3.1, Importance of pH in everyday life. Are plants and animals pH sensitive? Our body works within the pH range of 7 to 7.8. Living organisms can survive only in narrow range of pH changes. When the pH of rainwater is less than 5.6, it is said to be acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. Next page. I hope the screen is visible. Do you know acids in other planets? The atmosphere of Venus is made up of thick white and yellowish clouds of sulfuric acid. Let me see. There are so many messages in the chat. Santosh Kumar Singh, I'm just reading. This is the audio. You can come back to my section. This is just the audio of chapter 2. Yes, I'm just reading because this is audiobook that I'm creating again for class 10 science. In case you are interested in hearing the audio with some background music, a playlist has already been uploaded. What is the pH of the soil in your backyard? Plants require a specific pH range for their healthy growth. To find out the pH required for the healthy growth of a plant, you can collect the soil from various places and check the pH in the manner described below in activity 2.12. Also, you can note down which plants are growing in the region from which you have collected the soil. Activity 2.12, put about 2 grams soil in a test tube and add 5 grams of water to it. Shake the contents of the test tube. Filter the contents and collect the filtrate in a test tube. Check the pH of this filtrate with the help of universal indicator paper. What can you conclude about the ideal soil pH for the growth of plants in your region? pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During the indigestion of stomach produces too much acid, and this causes pain and irritation. To get rid of this pain, people use bases called antacids. One such remedy must have been suggested by you at the beginning of this chapter. These antacids neutralize the excess acid. Magnesium hydroxide or milk of magnesia, a mild base, is often used for this purpose. pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel made of calcium hydroxyapatite, a crystalline form of calcium phosphate, is the hardest substance in the body. It does not dissolve in water but is corroded when the pH of the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of the sugar and the food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food using toothpaste, which are generally basic for cleaning the teeth, can neutralize the excess acid and prevent tooth decay. Self defense by animals and plants through chemical welfare. Have you ever been stung by a honeybee? Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves ingest methanoic acid causing burning pain. Next page. Nature provides neutralization options. Nettle is a herbaceous plant which grows in the wild. Its leaves have stinging hair, which causes painful stings when touched accidentally. This is due to the methanoic acid secreted by them. A traditional remedy is rubbing the area with the help of a leaf of the dog plant. When often which often grows beside the nettle in the wild. Can you guess the nature of the dock plant? So, next time you know what to look out for if you accidentally touch a nettle plant while trekking. Are you aware of any other effective traditional remedies for such things? Table 2.3, some naturally occurring acids. So, vinegar has acetic acid, orange has citric acid, tamarind tartaric acid, tomato oxalic acid. Ant sting and nettle sting has methanoic acid, and sour milk, that is curd, and lemon, they have different. So, sour milk has lactic acid and lemon has citric acid. In text questions. So there are three questions being seen on the screen. We'll read them once. One, you have two solutions A and B. The pH of the solution A is 6 and the pH of the solution B is 8. Which solution has more hydrogen ion concentration? Which of these is acidic and which one is basic? Question number two, what effect does the concentration of H plus aqueous ions have on the nature of the solution? Do basic solutions also have H plus aqueous ions? If yes, then why are they these basic? Under what soil condition do you think a farmer would treat the soil of his fields with quick lime calcium oxide or slaked lime calcium hydroxide or chalk calcium carbonate? 2.4 more about salts. In the previous sections, we have seen the formation of salts during various reactions. Let us understand more about their preparation, properties, and uses. 2.4.1 Family of salts. Activity 2.13. Write the chemical formula of the salts given below: potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride and sodium nitrate, sodium carbonate, and ammonium chloride. Next page. I hope the screen is clear. I'm just coming back in a minute. Just need to wet my throat by taking water. So we are here on this page now. Identify the acids and bases from which the above salts may be obtained. Salts have the same positive or negative radicals are said to belong to a family. For example, NaCl, Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. How many families can you identify among the salts given in this activity? 2.4.2 pH of salts. Activity 2.14, collect the following salt samples like sodium chloride, potassium nitrate, aluminium chloride, zinc sulfate, copper sulfate, sodium acetate, sodium carbonate, and sodium hydrogen carbonate. Some other salts available can also be taken. Check their solubility in water. Use distilled water only. Check the action of these solutions on litmus and find the pH using pH paper. Which of the salts are acidic, basic, or neutral? Identify the acid or base used to form the salt. Report your observations in table 2.4. Salts of a strong acid and a strong base are neutral, while pH value of 7. On the other hand, salts of strong acid and weak base are acidic, while pH value is less than 7, and those of a strong base and weak acid are basic in nature, and the pH value is more than 7. 2.4.3. Chemicals from common salt. By now, you have learned that the salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that you use in food. You must have observed in the above activity that it is a neutral salt. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to impurities. This is called the rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. You must have heard about Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Next page. Common salt, a raw material for chemicals. The common salt, thus obtained, is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide, when electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. The process is called chlor-alkali process because of the products formed, chlor for chlorine and alkali for sodium hydroxide. So the reaction for this is 2NaCl aqueous plus 2H2O liquid will give you 2NaOH aqueous plus Cl2 gas plus H2 gas. Chlorine gas is given off at the anode and the hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products produced in this process are all useful. Figure 2.8 shows the different uses of these products. Like Cl2 is being used further for water treatment, swimming pools, PVC, disinfectants, CFCs, and pesticides. Cathode has hydrogen gas, which is used for fuels, margarine, ammonia for fertilizers. Brine that containing NaOH is used for degreasing metals, soaps and detergents, paper making, and artificial fibers. So the setup for the chlor-alkali process is given to you in figure 2.8. Now we are moving ahead to the bleaching powder. You have already come to know that chlorine is produced due to the electrolysis of the aqueous sodium chloride or brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on slaked dry lime, CaOH2. Bleaching powder is represented as CaClO, ClNO with B2 atoms each. So that is why bracket is along this side. Though the actual composition is quite complex. So it is 2CaOH2 plus 2Cl2 will give you CaClO in bracket chlorine and oxygen 2 plus CaCl2 plus 2H2O. Next page. Bleaching powder is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching wash clothes in laundry. As an oxidizing agent in many chemical industries and to make drinking water free from germs. Baking soda. The baking soda is commonly used in the kitchen for making tasty, crispy pakoras, etc. Sometimes it is used for faster cooking. The chemical name of the compound is sodium hydrogen carbonate or NaHCO3. It is produced using sodium chloride as one of the raw materials. So when NaCl is added to H2O plus CO2 plus NH3, which is ammonia, it will give you ammonium chloride as NH4Cl plus NaHCO3 sodium hydrogen carbonate. Did you check the pH of the sodium hydrogen carbonate in activity 2.14? Can you correlate why it can be used to neutralize an acid? It is a mild, non corrosive basic salt. The following reaction takes place when it is heated during cooking. So, whenever sodium hydrogen carbonate or 2NaHCO3 is heated, it is going to form sodium carbonate Na2CO3 plus H2O plus CO2. Sodium hydrogen carbonate has got various uses in the household. Uses of baking soda for making baking powder, which is a mixture of baking soda, sodium hydrogen carbonate, and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. NaHCO3 plus H plus from any acid, CO2 plus H2O plus sodium salt of acid. Carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. Sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. Washing soda. Another chemical that can be obtained from NaCl or sodium chloride is Na2CO3.10H2O washing soda. You have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt. So when sodium carbonate is added with 10 molecules of water, it is going to form washing soda. The chemical formula is Na2CO3.10H2O. Next page. What does 10H2O signify? Does it make Na2CO3 wet? We will address this question in the next section. Sodium carbonate and sodium hydrogen carbonate are used full chemicals for many industrial processes as well. Uses of washing soda. Sodium carbonate or washing soda is used in glass, soap, and paper industry. It is used in the manufacture of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. 2.4.4 are the crystals of salts really dry. Activity 2.15. Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of the copper sulfate after heating? Do you notice water droplets in the boiling tube? Where have these come from? Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? Next. Copper sulfate crystals, which seem to be dry, contain water of crystallizations. When we heat the crystals, this water is removed and the salt turns white. If you moisten the crystals again with water, you will find that blue color of the crystals reappears. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Five water molecules are present in one formula unit of copper sulfate. Chemical formula for hydrated copper sulfate is CuSO4.5H2O. Now you would be able to answer the question whether the molecule of Na2CO3 10H2O is wet. On the other, one other salt which possesses water of crystallization is gypsum. It has two water molecules as water of crystallization. It has the chemical formula CaSO4.2H2O. Let us look into the use of this salt. Plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate, written as CaSO4.half H2O. This is called plaster of Paris. The substance which doctors use as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with water, it changes to gypsum, once again giving a hard solid mass. So POP may, whenever we're going to add 1.5 molecules of water, it is going to produce CaSO4.2H2O, which is gypsum. Note that only half a water molecule is shown to be attached as water of crystallization. How can you get half a water molecule? It is written in this form because two formula units of CaSO4 share one molecule of water. Plaster of Paris is used for making toys, materials for decoration, and also used for making the surfaces smooth. Try to find out why is calcium sulfate hemihydrate called plaster of Paris. In text questions, question number 1. What is the common name of the compound CaClO2? Name the substance which on treatment with chlorine yields bleaching powder. Third question, name the sodium compound which is used for softening hard water. Fourth, what will happen if a solution of sodium hydrogen carbonate is heated? Give the equation of the reaction involved. Write an equation to show the reaction between the plaster of Paris and the water. So the summary of the chapter is acid-base indicators are dyes or mixtures of dyes which are used to indicate presence of acids and bases. Acidic nature of a substance is due to the formation of H plus aqueous ion in solution. Formation of OH negative ions in solution is responsible for the basic nature of a substance. When an acid reacts with a metal, hydrogen gas is evolved and a corresponding salt is formed. When a base reacts with a metal along with the evolution of hydrogen gas, a salt is formed which has a negative ion composed of the metal and oxygen. When an acid reacts with a metal carbonate or metal hydrogen carbonate, it gives the corresponding salt, carbon dioxide gas, and water. Acidic and basic solutions in water conduct electricity because they produce hydrogen and hydroxide ions respectively. The strength of an acid or an alkali can be tested by using a scale called pH scale that runs from 0 to 14, which gives the measure of hydrogen ion concentration in a solution. A neutral solution has a pH of exactly 7, while an acidic solution has a pH less than 7, while basic has a pH of more than 7. Living beings carry out their metabolic activities within an optimal pH range. Mixing concentrated acids or bases with water is a highly exothermic process. Acids and bases neutralize each other to form corresponding salts and water. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Salts have various uses in everyday life and in industries. So, with this, we are done with the reading of chapter 2, acid, bases, and salts. We were able to finish it approximately in 45 minutes. Whenever you'll be hearing the audio of this, please do share it with your friends. So this is video 2 of the series audiobook of class 10 science. In case you are looking for the video series on life processes, the explanation of the chapter and heredity which are not given good in NCRT, you can also check out the explanatory videos in the playlist on my channel. Consider subscribing so that you can get the notification of the recent updates as well. See you in next video with chapter 3 live reading.